Have you ever seen someone hammering a nail? What drives a nail into the wood? Or have you ever seen an aircraft flying across the sky? What keeps a huge, heavy airplane flying in the air instead of falling out of the sky? Both examples illustrate the concept of force. A force is anything that can cause a change to objects. Force can change the shape of an object, move or stop an object, and change the direction of a moving object. Now, we will learn about the basics of forces and force diagrams. The first basic of force is weight. The symbol for weight is capital W. Weight is a force exerted on a body under gravitational field. Weight is always directed toward the center of the earth. The second basic force is tension in the string, rope, or cable. The symbol for tension is capital T. Tension is pulling force that is directed away from the object and attempt to stretch or elongate the object. The third basic force is normal force, or also known as reaction force. The symbol for normal or reaction force is capital N or capital R. Normal force is a reaction force that is exerted by the surface to an object that interacts with it. The direction of normal force is always perpendicular to the surface. The fourth force is frictional force, and the symbol is small letter f. Frictional force is a force that resists the motion of one surface relative to another with which it is in contact. The direction of the frictional force is opposite direction of the motion. Frictional and reaction force are always perpendicular to each other. The fifth force is push force, like when someone pushes a box across a floor and the symbol is capital F. The sixth force is pull force. The symbol is capital F. Dragging a box is one of the examples of pull force. Now, let us combine the force diagram to draw a free body diagram of an object. Free body diagram is a diagram used to show the relative magnitude and direction of all forces acting upon an object in a given situation. There are 4 steps in drawing a free body diagram. The first is to use one dot to represent the starting point of the free body diagram. The second step is to draw arrows. The direction of this arrow indicates the direction of the forces. The third step is to label the arrows and to make sure each arrowhead is pointing into the right direction. Finally, the fourth step is the length of each arrow that will indicate the magnitude of the forces. Now, let us draw a free body diagram of the box moving up through an inclined plane in this situation. Combine a few of the force diagrams and follow the fourth step of drawing free body diagram to draw the free body diagram on the box. For the inclined plane, this is X component and this is Y component. Start with a dot. The weight is always directed downward. The normal force is perpendicular to the surface and must have contact with the surface. Tension is directed away from the object. And the surface of the inclined plane is rough. The friction is directed in opposite direction of the motion.